Hello everyone, welcome to Math Archives. In this video, let me discuss about an example under Fourier Series in an interval 0, 2 pi. For that, let me take an example. Obtain the Fourier Series to represent the function f of x is equal to 1 divided by 4 pi minus x the whole square in a closed interval 0, 2 pi. Hence, obtain these three series. First, what we are going to do is, firstly we have to derive the Fourier series representation of the given function. Before that, let me have a short look over the formulas that we are going to use in this problem. The very important first problem we are going to say is the Bernoullis Formula. Whenever you are having a product of two functions in the integral, so we make use of this formula. Here both u and both v, that is both u and v are functions of x. If so, by making use of this formula, we have to evaluate the integral and its value. So, integral uv dx is equal to uv1 minus u dash v2 plus u double dash v3 minus etc. Here, both u and v are functions of x. U dash, u double dash and u triple dash etc. These are successive derivatives of u. Whereas v1, v2, v3 etc. These are all successive integrals of v. Here, shall we write u dash as du by dx and u double dash as d square u by dx square and u triple dash as t cube u by dx cube etc. That is, once you have to differentiate that with respect to x means that is u dash. Twice means u double dash. Thrice means u triple dash etc. So, next v1, v2, v3. So, v1, v2, v3 are successive integrals, whereas v1 is nothing but integral v dx, v2 is integral v1 dx and v3 is integral v2 dx etc. Then next, you should know the values of cos n pi, cos 2n pi. Cos n pi value is minus 1 whole power n, cos 2n pi is plus 1, whereas sin n pi and sin 2n pi both are 0 if n is an integer. So, here we are going to take only integer values. So, both sin n pi and sin 2n pi become 0. Besides that, you should know the value of cosine 0, that is 1, whereas sin 0 value is 0. This is the basic integral and differentiation formula, that is integral x power n dx is equal to x power n plus 1 divided by n plus 1, whereas d by dx of x power n is equal to nx power n minus 1. So, suppose if we are going to integrate x square with respect to x, what is the answer we have obtained is x cube divided by 3, that is x power n plus 1 means 2 plus 1 divided by 2 plus 1, that is x cube by 3, whereas if you are going to differentiate the same function with respect to x, what you get? Nx power n minus 1, so 2x power 2 minus 1, that is 2x power 1, that is 2x. Next, integral cos nx dx is equal to integral cos nx dx values sin nx divided by n, whereas integral sin nx dx is equal to minus cos nx divided by n. So, with this short introduction about the basic formulas, let me now move on to the problem. First, we have to find out the Fourier series representation of the function f of x is equal to 1 by 4 pi minus x the whole square. So, here the given function is f of x is equal to 1 divided by 4 pi minus x the whole square. It is defined in an interval, closed interval 0, 2 pi. You know already the general Fourier series representation of any function f of x defined in the interval 0, 2 pi is f of x is equal to a0 divided by 2 plus sigma n varies from 1 to infinity an cos nx plus sigma n varies from 1 to infinity bn sin nx. Here a0, an and bn all are constant. These constants are calculated by making use of the Euler's formula. So, here a0 is calculated by making use of the formula 1 divided by pi integral 0 to 2 pi f of x dx, and an is calculated by making use of the formula 1 divided by pi integral 0 to 2 pi f of x cos nx dx, and bn is calculated by making use of the formula 1 divided by pi integral 0 to 2 pi f of x sin nx dx. Let me calculate all these values of a0, an and bn. So, after calculating all these values, substitute in f of x, we get the Fourier series representation of the given function. So, let me start our calculation. Let me start with the value of a0. For calculating the value of a0 first, So you know the formula for calculating A0. A0 is equal to 1 divided by pi integral 0 to 2 pi f of x dx. So what is the given function? So the function given in our problem is, that is f of x is equal to 1 divided by 4 pi minus x the whole square dx. So 1 by 4 is a constant, so take it outside of the integration. So 1 divided by 4 pi integral 0 to 2 pi minus x the whole square dx. So that is equal to 1 divided by 4 pi integral x square dx. Integral x square, pi is a constant, so you have to take integral x square dx. What is integral x square dx? X cube, that is pi minus x the whole cube divided by 3. But here instead of having plus x, here you have minus x, isn't it? So you have minus. So while you are differentiating minus x, you get minus 1, that is minus 3. So with the limit from 0 to 2 pi. So you take this minus 2 outside and also 3 also outside of this bracket, you get minus 1 divided by 12 pi minus x the whole cube with the limit from 0 to 2 pi. So let me first substitute the upper limit for x as 2 pi and then minus lower limit as 0. So here a0 is equal to minus 1 divided by 12 pi. I am just write down the previous step once again. So pi minus x the whole cube with the limit from 0 to 2 pi. Let me first substitute the upper limit, that is 1 divided by 12 pi. Here upper limit is pi minus, replace x by 2 pi. Replace x by first 2 pi minus, replace x by 0, that is pi minus 0 whole cube. So that is equal to minus 1 divided by 12 pi. So pi minus 2 pi is minus pi cube, minus pi minus 0 is pi itself, so you get pi cube alone. So that is equal to minus 1 divided by 12 pi. So minus pi cube and minus pi cube. So here you have minus pi cube, that is minus 2 pi cube. What happens? This minus and minus becomes plus, then 6 2s are 12, cancelling the common terms. So and here you have pi, here pi cube, so pi square, isn't it? So you have pi square divided by 6. So here the value of a0 we calculated as pi square divided by 6. Next we calculate the value of an. For that we make use of the formula. An is equal to 1 divided by pi integral 0 to 2 pi f of x cos nx dx. This is the formula we have to use for calculating the value of an. First let me replace the function value f of x by 1 divided by pi integral 0 to 2 pi. The given function is 1 divided by 4 pi minus x the whole square cos nx dx. Here 4 is a constant, so you take it outside of this integral. So 1 divided by 4 pi integral 0 to 2 pi minus x the whole square cos nx dx. So here we are having product of two functions, whereas two functions are functions of x. Here the integrand is with respect to x. Here also we have product of two functions, whereas two functions also functions of x. So we couldn't evaluate this integral by using the simple formulas. So for that we make use of the Bernoullis Formula, as I told you already. So the Bernoullis Formula we are going to use integral uv dx, that is equal to uv1 minus u dash v2 plus u double dash v3 plus etc. This is what the formula we are going to use now. So for that you take first term as u and second term as v. So what is your u? First I am going to differentiate u with respect to x one time, two times. Okay. So here u is pi minus x the whole square. So if you are very thorough about this formula, you have to directly move on to the formula. That is, you have to directly write down u v1 minus u dash v2 plus etc. So if you are a beginner for solving this problem, so for that I just give you a detailed explanation at this step. So your u is pi minus x the whole square. So what is your u dash? u dash is you are going to differentiate it. That is pi minus x the whole square. If you are going to differentiate it, you get twice pi minus x. Then you have to differentiate this. While you differentiating pi, you get 0, minus while you differentiating x, you get minus 1. Okay, this is your u dash. Next we move on to u double dash. U double dash means you have to differentiate u dash again with respect to u, that is your u double dash. So here 2 is a constant, twice, here pi is a constant, so if you differentiate pi you get 0, minus x. If you differentiate x with respect to x you get 1. Here minus 1 is a constant. Next we move on to u triple dash. U triple dash is nothing but again you have to differentiate u double dash with respect to x once again. Look at here. Here all are constants. 2, minus 1, all are, while you differentiating constant value you get 0. So let me start this formula up to this. Okay. So corresponding values of v1, v2, v3 you have to calculate because u v1. So for that you need the value of v1. The second term is u dash v2. For that you need the value of v2. The third term is u double dash v3. So for that you need the value of v3. And you don't need the next value because u triple dash becomes 0. So the formula end up to the first. It is an infinite formula. It stops whenever the value of u double dash or the derivative of u becomes 0 means we have to stop. Okay, so we have to continue up to u double dash. In the formula we have to continue up to u double dash, whereas u triple dash 0. So we have to calculate only v1, v2, v3, that's enough. Okay, so your v1 is, this is your v. So your v1 is cos nx. If you integrate cos nx, what you get? Sin nx divided by n. Integrating cos nx, you get sin nx divided by n. Next v2 is, again you have to integrate v1 with respect to x. So now we have to integrate this sin nx divided by n once again. So 1 by n is a constant. So integrating sin nx you get minus cos nx divided by n. Already you have n in the denominator, so that becomes n square. Coming to v3, v3 is nothing but integral v2. That is again you have to integrate this v2 with respect to x once again. That is minus 1 by n square is a constant. Next, integrating cos nx you get sin nx. So sin nx divided by n. Already you have n in the denominator, so that becomes n cube. That's all. Now let me substitute the formula and we proceed as usual. Okay. Now, so your an is equal to 1 divided by 4 pi u v1. What is your u? Pi minus x the whole square. v1 is sin nx divided by n minus u dash, that is twice pi minus x minus 1. Then u dash v2. v2 is minus cos nx divided by n square plus, so I am just write on the third term here, twice pi minus 0 minus 1 of minus sin nx divided by n cube. Here the limit is from 0 to 2 pi. Now let me simplify the symbols. That is, here we have 3 negative terms, so negative. Here we have only 2 negative terms, so that is positive. So in the next step, don't substitute the limits. Let me first simplify the symbols minus as positive or negative, whatever that may be, we have inside. Okay. So first term it doesn't have any problem. So write down the as it is, pi minus x whole square product sin nx divided by n. Whereas in the second term we are having 3 minus. So 3 minus becomes plus. Here we have plus. Twice pi minus x. So this minus and minus becomes plus, so no need to write this term. So cos nx divided by n square. Your next term minus become positive, already you have positive, so plus 2 pi sin nx divided by n cube with the limit from 0 to 2 pi. Now let me substitute the limit. As usual, upper limit minus lower limit is the process we are going to follow. So you know already. So let me first substitute the upper limit minus lower limit. So here the bracket is must, that's why I have to write down the bracket first. First bracket is for upper limit minus lower, second bracket is for lower limit, and then we have to cover these two by a whole bracket. Now, so first let me replace the value of x by 2 pi. If you replace this x by 2 pi, what happens? Here you get sine 2n pi. You know the value of sine 2n pi, that is 0. 0 into anything, 0. First term becomes 0 because sine 2n pi value 0. Coming to the second term, replace x by pi twice pi minus 2 pi. Cos 2n pi value is nothing but plus 1. So you have here 1 by n square. Plus, because cos, if you replace x by 2 pi, 2n pi, you know the value of cos 2n pi, that is plus 1. Coming to the third term, sine 2n pi. You know the value of sine 2n pi, that is 0. So the entire term becomes 0. Upper limit over. Minus. Coming to the lower limit, if you replace x by 0, what happens? Look at first sine or cosine terms. Okay. So sine 0, 0. So first term 0. Plus twice pi minus 0. Cos 0. You know the value of cos 0. Cos 0 value is 1. 1 divided by n square. Plus coming to the third term, you know the value of sine 0, isn't it? Sine 0 value is 0, so the entire term becomes 0. Simplifying this, you get the value of an. So 1 divided by 4 pi, twice pi minus 2 pi is nothing but minus pi divided by n square. Minus here 2 pi by n square, isn't it? 2 pi by n square. Okay, so here what you get here, minus 2 pi divided by n square. So that is equal to sorry, I made a mistake here. So 3 minus here becomes minus itself, isn't it? 3 minus is minus. So here we have changed this plus to minus and this here minus. Sorry, I made a mistake. 3 times minus means minus. So here you have minus of 2 times minus pi divided by n square, minus of here you have plus, isn't it? Minus and minus becomes plus. So that is equal to 1 divided by 4 pi, 2 pi divided by n square plus 2 pi divided by n square. So that is equal to how many times? That is equal to 1 by 4 pi of 2 pi plus 2 pi. That is nothing but 4 pi divided by n square. So 4 pi and 4 pi being cancelled, so you get only 1 over n square. So the value of an we have calculated as 1 over n square. That's all. So now we calculated the value of n. Next we calculate the value of bn. So you know the formula for calculating bn. bn is equal to 1 divided by pi integral 0 to 2 pi f of x sine nx dx. First we replace f of x by the given function, that is 1 divided by 4 pi minus x the whole square sine nx dx. Here 4 is constant, so you take it outside of the integral. 1 divided by 4 pi integral 0 to 2 pi minus x the whole square sine nx dx. Here itself we have the same case. Here the product of two functions are functions of x. So here itself we make use of the formula integral u v dx is equal to u v1 minus u dash v2 plus u double dash v3 plus etc. We make use of this Bernoulli formula. For that, first you have to take the first term as u and second term as v. So as usual, you are very well thorough about this formula, means directly you have to write down the next step, that is applying the Bernoullis formula. You can directly write down the steps. So otherwise, if you are a beginner, I am just write down how we are going to proceed to calculate these product of functions using Bernoullis formula. So u is pi minus x the whole square. So u dash is nothing but twice pi minus x. This is the same case, that is what we have discussed in case of an. There is no change in u dash, u double s, u triple s, so I have to write down these without giving much explanation. Okay, twice pi minus x minus 1, whereas u double s is nothing but twice pi minus 0 minus 1, whereas u triple s is 0. Next, here the only change in v. For calculating an, here we have cos nx. For calculating bn, here we have sin nx. Here we calculate both v1, v2 and v3. So for calculating v1, you have to integrate v with respect to x. So sin nx is nothing but minus cos nx divided by n. So if you are going to again integrate with respect to n, minus 1 by n is constant. Integrating cos nx, you get sin nx divided by n, that is divided by n square. Already you have n in the denominator. Next, minus 1 by n square is constant. So if you integrate sin nx, you get minus cos nx. Already you have minus, so that becomes plus. So cos nx divided by n cube, because already you have n square in the denominator. And substituting the formula u v1 u dash v2 and substituting the limit to get the value of b1. Now bn is equal to 1 divided by 4 pi u v1. What is your u? U is nothing but pi minus x the whole square. v1 is nothing but integrating sin nx, you get minus cos nx divided by n, minus u dash is nothing but twice pi minus x minus 1. v2 is nothing but minus sin nx divided by n square, plus u triple dash twice pi minus 0 minus 1 and minus sin nx becomes plus cos nx, isn't it? So cos nx divided by n cube. Here the limit is from 0 to 2 pi. Let me first simplifying the symbols. So 1 divided by 4 pi, first term we have minus. So pi minus x the whole square minus cos nx divided by n. So here we have 1, 2, 3 minus terms. So if it is 3 minus negative, so there I made a mistake. So 3 minus means negative. Odd number of negative or negative itself. Even number of negative term means we get positive, isn't it? So twice pi minus x sin nx divided by n square, plus here you have twice 2 pi minus 0 minus. So what you get? Minus plus. So instead of plus, here you have minus 2 pi cos nx divided by n cube, with the limit from 0 to 2 pi. Okay. Now let me substitute the limit. First upper limit minus lower limit as usual. So upper limit minus lower limit. Okay. First let me replace x by 2 pi. What happens? Pi minus 2 pi. Okay. I am going to write down the values directly. So pi minus 2 pi. Pi minus 2 pi value is pi minus 2 pi, that is minus pi square, that is pi square itself, and minus of cos 2n pi. Cos 2n pi value is nothing but 1, so minus 1 divided by n. And just write down the values directly. Minus, so whatever may be this value, sin 2n pi value is 0, so this term becomes 0. Minus coming to the next term, 2 pi cos and 2n pi divided by n cube, that is 2 pi 1 divided by n cube, isn't it? So minus coming to the lower limit, so we have to replace the value of x by 0. So here you have pi square, cos 0 is nothing but minus 1 divided by n, minus sin 0 value you have, you know that is 0, minus 2 pi cos 0 value is 1 divided by n cube. That's all. So simplifying this, you get 1 divided by 4 pi. So here you have minus pi square divided by n minus 2 pi divided by n cube. So here minus and minus becomes plus. So plus pi square divided by n. Here minus and this minus becomes plus. So 2 pi divided by n cube. What happens? So this pi square by n and this pi square by n cancel, and this one being cancelled, the resulting value we have obtained as 0. 1 by 4 pi, that is 1 by 4 pi product 0. That is nothing but 0. So the value of Bn we calculated as 0 for this problem. So now we calculated the values of A0, An and B1. Substitute all these values in f of x. You know already f of x is equal to A0 divided by 2. That is a general Fourier series representation of the given function. Sigma n varies from 1 to infinity an cos nx plus sigma n varies from 1 to infinity bn sin nx. Let me substitute the values of A0, An and Bn. You know, we calculate the value of A0 as pi square divided by 6 divided by 2 plus sigma n varies from 1 to infinity, and we calculate the value of An, that is as 1 divided by n square cos nx, and the value of Bn is 0, so this term becomes 0. So your f of x is equal to, so pi square divided by, so take this to denominator, so pi square divided by 12 plus sigma n varies from 1 to infinity 1 divided by n square cos nx. So this is what the Fourier series representation of the given function f of x is equal to 1 divided by 4 pi minus x the whole square, that is defined in a closed interval 0, 2 pi. So let we find out the Fourier series representation of the given function f of x. After that we are having some more work in the deduction part. That is, here we have only cosine series. We doesn't have any sine series. We have to deduce 3 different types of series. So for the deduction part, we are going to deduce the first series. So you know what we are going to deduce in the first series. We have to deduce 1 by 1 square plus 1 by 2 square plus 1 by 3 square plus 1 by 4 square plus etc. That is equal to pi square by 6. This is what we are going to deduce from the Fourier series. So look at here, this is the Fourier series, general Fourier series of the given function f of x. Here we have only cosine terms. As I told you already, if you are going to derive a cosine series, in most of the cases the substituting x equal to 0 or x equal to pi gives you the series, that is what we are going to deduce. Okay, so x equal to 0 gives you series of all positive terms, whereas x equal to pi gives you series of all negative terms and positive terms alternatively, that is minus plus etc. In most of the cases, okay, this is not a rule. In most of the cases cosine series is obtained by putting x equal to 0 or x equal to pi. Here we have only cosine series. So look at here, what we are going to deduce: 1 by 1 square plus 1 by 2 square plus 1 by 3 square, that is sum of the series. Okay, sum of the series means definitely I am going to take, I am just write on the general Fourier series representation here once again, that is pi square divided by 12 plus sigma n varies from 1 to infinity 1 divided by n square cos nx, right? So to reduce this series, I am going to substitute put x equal to 0, because x equal to 0 gives you sum of all positive terms of the series. So which is a, you know already, function, already we have discussed about this topic in detail under convergence of Fourier series. So f of x is equal to 1 by 4 pi minus x the whole square is a given function that is defined in a closed interval 0, 2 pi. In closed interval 0, 2 pi means what it means, that is x is continuous at all points including 0 and 2 pi. X is continuous at all points including 0 and 2 pi. So x equal to 0 is a, which is a continuous point. Which is a continuous point. If it is a continuous point, then what happens? So under convergence theorem on Fourier series, we have discussed about this in detail. I will give you the link in the description. So if the point is continuous, what we do? We have to substitute the value directly. If it is discontinuous, we have 2 more cases. Okay. So if it is continuous, what we do? We have to substitute the value directly. Just replace the value, that is the point where we have to calculate the function value, just replace that value in the function, you get the function value. Okay, so now then we have f of, so in f of x replace x by 0, what you get? F of 0 is equal to pi square over 12 plus sigma n varies from 1 to infinity 1 over n square cos 0. So f of x, f of 0, what is the meaning of f of 0? That is f of x at x equal to 0 we have to calculate. Okay, at x equal to 0 what we calculate means we have to first find out whether that point is a continuous point or discontinuous point. Here x equal to 0 is a continuous point. If it is a continuous point, what we do? We have to substitute the value directly in the function, that is f of x equal to 1 by 4 pi minus x the whole square. So you have to say f of 0 1 by 4 pi minus, replace just x by 0, pi minus 4, that is pi minus 0 the whole square. Okay, here we replace x by 0, that is your f of 0, that is equal to pi square divided by 12 plus sigma n varies from 1 to infinity 1 divided by n square. You know the value of cos 0, the value of cos 0 is 1, right? Simplifying this you get pi square divided by 4 is equal to pi square divided by 12 plus sigma n varies from 1 to infinity 1 divided by n square. We need this summation value, that is sum of this value series alone. So keep this one side, take this term to this side, what happens? So sigma n varies from 1 to infinity 1 divided by n square is equal to pi square divided by 4 minus pi square divided by 12. Take an LCM as 12, what happens? So divided by 12 means here you have to multiply both numerator and denominator by 3 times. That is 3 pi square minus pi square. 3 pi square minus pi square is nothing but 2 pi square divided by 12. That is pi square divided by 6. So sigma n varies from 1 to infinity. If you expand this series, what you get? 1 by 1 square plus 1 by 2 square. Substituting n is equal to 3, 4, etc. That is equal to pi square divided by 6. This is what the series we have obtained. For that we substitute the value x equal to 0 for x. So then we move on to the second one. The second part, we have to deduce the series of the form 1 by 1 square minus 1 by 2 square plus 1 by 3 square minus 1 by 4 square plus etc. That is equal to pi square divided by 12. This is what we are going to deduce in the next one. So as I told you already, and just write down the Fourier series of the given function we have derived just now, that is f of x equal to pi square divided by 12 plus sigma n is equal to 1 to infinity 1 divided by n square cos nx. So here look at the series, this is a series of alternatively positive negative. Here we have only cosine series. If it is of series of all alternatively positive negative means, as I told you already, you just substitute put x equal to pi. Okay, which is if it is pi, as I told you already, f of x is equal to 1 divided by 4 pi minus x whole square is a given function that is defined in the closed interval 0, 2 pi. Okay, which means x is continuous at all points including 0 and 2 pi. Here pi is approximately, this is 0 and 2 pi. Pi is approximately here, which means that is a continuous point. So which is a continuous point. So what we do, as we do in case of previous one, so we have to directly replace the value of x by 0 in the given function. So f of 0, that is equal to, f of pi is equal to pi square divided by 12 plus sigma n varies from 1 to infinity 1 divided by n square cos n pi. What is f of pi? Replace x by pi. So your f of x is 1 by 4 pi minus x whole square. So your f of pi is, f of pi means f of x at x equal to pi. That is the meaning. Okay. So f of pi is 1 by 4 pi minus, if you replace pi by pi, what happens? Pi minus pi the whole square. That is equal to, the right hand side you have pi square divided by 12 plus sigma n varies from 1 to infinity 1 divided by n square cos n pi value is minus 1 whole power n. So here pi minus pi means that becomes 0, that is equal to pi square divided by 12 plus sigma n varies from 1 to infinity. If you expand this series, so first I have to write down, so 1 divided by n square minus 1 whole power n. Now take this term to other side and keep this summation along this time, this side. So you have minus pi square divided by 12, that is equal to sigma n varies from 1 to infinity 1 divided by n square minus 1 whole power n. Now we have to expand this series by substituting n is equal to 1, 2, 3, etc. So if you are doing so, I am going to write here. So I am just write on the previous step once again. So minus pi square divided by 12 is equal to sigma n varies from 1 to infinity 1 divided by n square minus 1 whole power n. That is minus pi square divided by 12, substituting n is equal to 1, what you get? 1 by 1 square, here you have minus 1. Plus 1 by 2 square, here you have minus 1 whole square. Plus 1 by 3 square minus 1 whole cube. Plus 1 by 4 square minus 1 whole power 4 plus etc. So what you get? Minus of 1 by 1 square minus 1 whole square becomes plus 1. So plus 1 by 2 square minus 1 cube is nothing but minus 1 by 3 square minus 1 whole power 1 plus 1 divided by 4 square minus etc. So here itself you have minus term. So cancelling minus term on both sides, what you get? Pi square by 12, or just you just take this minus to this side, whatever that may be. So what happens? First term become positive because that's negative. So all sign changes, minus plus 2 plus minus, only that is the difference. Okay, 1 by 1 square minus 1 by 2 square plus 1 by 3 square minus 1 by 4 square plus etc. So this is what we have to deduce as a second part. Now look at the third one. What is the third part we are going to derive as? Third one is 1 divided by 1 square, 1 divided by 1 square plus 1 divided by 3 square plus 1 divided by 5 square plus etc. That is equal to pi square divided by 8. This is the next part we have to deduce. So in cosine series, if we are going to deduce the third part, that is here in between we have this one term, which means by adding the previous two series gives you this series. That is the meaning of this one. So the first two series we have deduced as, I am just writing it here. First series we have obtained by substituting x equal to 0 as 1 by 1 square plus 1 by 2 square plus 1 by 3 square plus 1 by 4 square plus etc. That is equal to pi square divided by 6. This one the first series we have to deduce, isn't it? By substituting x equal to 0. And by substituting x equal to pi, we reduce the second series as 1 divided by 1 square minus 1 divided by 2 square plus 1 divided by 3 square minus 1 divided by 4 square plus etc. That is equal to pi square divided by 12. So what we are going to do here is adding these two series. Okay, adding 1 and 2, isn't it? This is the first series we have to derive and this is the second one. Adding these two, we get the third series. We get by adding these two, what we get? So what happens? This 1 by 1 square plus, so twice you get, isn't it? 2 times you have 1 by 1 square. I am just write down 2 as a common term, take it outside. The second term plus minus, so cancel. Coming to third term, 1 by 1 3 square plus 1 by 3 square. You have 2 times, so I already take 2 as common term. So 1 by 3 square. The next term alternatively, this is plus, this is minus, cancel. What is your next term? Plus 5 square, isn't it? Plus etc. Okay, that is equal to, and to the right hand side adding these two, that is pi square by 6 plus pi square by 12. So taking an LCM as 12, so here you have 2 times pi square plus pi square divided by 12, isn't it? So multiplying this term numerator and denominator by 2 times, you have 12. So 12 as an LCM. So here you have 2 times the series, isn't it? So simplifying this, we get, it is, I have tried the previous step once again. So twice 1 by 1 square plus 1 by 3 square plus 1 by 5 square, that is equal to 2 pi square plus pi square divided by 12, isn't it? That is, you have here 3 pi square divided by 12, that is pi square divided by 4. So here twice 1 by 1 square plus 1 by 3 square plus 1 by 5 square plus etc. that is equal to pi square by 4. So you need this series alone. So take this 2 to other side. What happens? 1 by 1 square plus 1 by 3 square plus 1 by 5 square plus etc. is equal to pi square divided by 4 2s are, that comes to the denominator, 4 2s are 8, that's all. So reduce the third series also. Up to this, hope you got a clear idea about how to calculate the Fourier coefficients for a given function defined in an interval 0, 2 pi. Thanks for watching. See you all again in my next video.